Hello everyone, welcome back to the another session. This video is continuation part of the convex hull. So this video will helps you out to understand how to implement this convex hull algorithm using Graham scan algorithm. So we'll go to that Graham scan right now. So what is Graham scan? Before you apply Graham scan algorithm, first of all consider set of S points on a plane. Now Graham scan algorithm identifies the point P from S with the lowest y coordinate value. This is what the first step of the algorithm. The very second step of the algorithm is what? We'll sort the point of S, performing sorting. We'll sort the point of S according to the angle subtended by the points of P with the positive x-axis. Now you can see this figure. After having sorted the points, if we scan through the sorted list starting at P, every 3 successive points will form a left turn if all these points lie on the hull. Left turn. Then this point will be in the convex hull, this point will be in the convex hull, this point will be in convex hull. On the other hand, if there were 3 successive points P1 and P2, I'll draw here P1, P2 and P3 that form a right turn, then we can immediately eliminate P2 since it cannot lie on the convex hull. Now let's assume that I have P1 and P2 and here I have some P3 and assume it is a P. So now after I join P1 to P2, now again I have to turn to this side, right? And once if I join this, again I have to turn to right side. So whereas if I turn to this side, it will not be in the convex hull. If I delete this thing, then I can join directly to P1 to P3, whereas this point, this extreme point will be inside of the polygon. And notice that it will be an internal point because it lies within the triangle formed by P, P1 and P3. P1, P2, P3. We can eliminate all the interior points using the above procedure. Starting from P, we consider 3 successive points P1, P2, P3 at a time. To begin with, P1 is equal to P. If these points form a left turn, we move to the next point. If not, we'll delete the P2 and we'll move to the next point. This process we finish until we finish all the extreme points and we'll come back to the P again. We'll take some example and we'll find the solution using Graham scan algorithm. So Graham scan algorithm is what? You have to first of all choose the y lowest coordinate. So I'm choosing this coordinate as y lowest, maybe x lowest or not, but I'm choosing this coordinate to move to find out the which vertex, which extreme points will be joined to make it is a convex hull. Now algorithm Graham scan which tries to find out the point which lies inside of the polygon in order to find the angle and sort them accordingly. So I'm choosing this y lowest or y minimum, x may be maximum or x may be minimum for this point. So the angle which makes from P, so I'm taking it as P, it as Q, it as R. So the angle which makes from P is less than that which makes by R. So what we will be doing is, we will be going to calculate the slope in between these two. That means the slope is what? In between these 2 points, Q into Y minus P dot Y by Q dot X minus P dot X. And whereas XY are corresponding to the X comma Y point. This is what? X comma Y point. Now, similarly, for Q and R also we'll calculate the slope R into Y minus Q into Y by R into X minus Q into X. All we need to do just to compare these two lines. Okay, now so we'll compare these two lines. We'll get a cross multiplication where it is r into x minus q into x, q into y minus p into y is equal to q into x minus p into x, r into y minus q into y. Now by bringing RHS to here, it becomes, if the value of this is 0, now it becomes what? If I bring this side, it becomes minus. Now if the value of this is 0, that means the 3 points, that means P, Q, R points are collinear. Because as those were in the same slope, if this value is greater 0, if this value is greater 0, if that value is greater 0, then P comma Q R will be making a clockwise angle. That means P Q R, clockwise angle. If it is less than 0, they are moving in a direction anti-clockwise. That means P Q R, this direction. As we saw in the previous figure in Graham-Scan algorithm, always we want an anti-clockwise angle, so we want to sort them in an increasing order. Now we will choose the point from where we are moving. Now let's see how we will be assume that P, just now we were taken this, right, to calculate the slope and to see the whether it is clockwise and anti-clockwise. We will be going for anti-clockwise. That means P comma Q R, the directions are what? P is here, Q is here, R is right to the P. Now so first of all we'll be naming to all these coordinates with the x1, x2, x3 and so on. So what we are going to do is we'll be going to join these two lines. Okay, that means which lines? x1 comma x2, that is we will be adding into, pushing into the stack. So once you find the angle in between these two, we will be going for x3. If I go for x3, then again I have to turn right to this x4 to join, right? So if I turn right again, what happens? Now x4, the anti-clockwise directions we are seeking for. So if I turn to this side, then x3 will be ignored. So that's what we are doing is, in order to join the line segment from x2 to x3, we are just joining from x2 to x4. So that means x3 is there, but we are not considering that. We will be writing x4. So the line segment will be existed from x2 to x4. Okay, now x4 again. We are at x4, so again we will be going for the other x5 in the same direction. Now here again you have to turn right to join the x6. If I take x6 in the stack, I have to turn right. So instead of turning right to join the x6, we will be going for x7. So I'm ignoring x6 and I'm writing x7. Now again x8, x9 and coming back to the x1 vertex. So here it is what? Convex hull. Because x3 and x6, though we are not connected, though we are not having any line segment, those are inside of the polygon. So finally the solution of this is what? x1, x2, x4, x5, x7, x8, x9 is the solution of this problem. So these are the extreme points through which we will be making a hull, convex hull. Now we'll see the complexity of this algorithm. So as far as Graham-Scan algorithm is considered, we'll take the vertex with the y minimum coordinate. So and this process will be for all the vertex what are there, that means of big O of n, and we'll sort the points, right? We'll not sort all the points because we will not join all the points. So that means the complexity of this will be big O of n log n. And for each point we'll do the same process. When each point I'm saying it is a complexity of big O of n. So add all these complexities, big O of n log n and plus big O of n. Finally it becomes big O of n log n. So this is what the complexity of Graham-Scan algorithm to find the solution for convex hull. We'll see even the algorithm of this. So algorithm of Graham-Scan is what? We will be scanning the list of points. So algorithm will scan the list of items, that is where the list is a pointer to the first node. So we'll take some double linked list, that is I am taking some pointer list and the other p1 is equal to list, because every time I have to take two extreme points to calculate the slope, right? So we'll be taking p2 is equal to p1 to next. And now condition is what? If p2 to next is equal to 0, then we will be just writing that, returning that it is an end of the list. If it is not equal to 0, then p3 is equal to p2 to next, else return. Now we'll be taking some temporary value, finding out the function area, that is p1 to x comma p1 to y comma p2 to x comma p2 to y, p3 to x comma p3 to y. If this value is greater than 0, then p1 is equal to p1 to next. If temporary value which I have calculated the area, if it is gives greater than or equal to 0, then p1 is equal to p1 to next. We will be pointing to the p1 to next. If p1, p2, p3 form a left turn, move 1 point ahead. That is what we are traveling in anti-clockwise. If it is not, delete p2 and move back. So that means else condition will move back. p1 to next is equal to p3. p3 to previous is equal to p1, because we are deleting the p2. Delete p2. That's it. And now finally p1 is equal to again to p1 to previous node. So this is what the algorithm to move in anti-clockwise direction from, if you consider 3 points of your extreme points of a set of S points. So this is what the algorithm. Thank you all.